Let's have a look at 9c, which is really quite similar to 9b. There's not much difference at all. So we've got x to the n, but in this case, n's a negative integer, so a negative whole number. So the first one we'll do, if we had f of x is 2 on x squared, I can write that as 2x to the minus 2. So when we find a derivative of that, we just go 2 times minus 2 is minus 4, x to the, and you take 1, minus 3. That is okay to leave it like that, or you could write it as minus 4 on x cubed. That's still the same thing. So there's no real difference to what we've been doing, it's just negative. What about this one? If we had x equals 6t cubed minus 5t on t to the 5, and we want to find dx dt, because x is in terms of t. First thing to do, and you might see some of these, and you can do it quicker than this, but I'll just show you by doing a bit more slowly. Because of what we know from the index laws, the 6 just stays there, and then we go 3 take 5 is minus 2, so that's 6t to the minus 2. This 5 stays there, and 1 minus 5, so it'll be minus 5t to the minus 4. So then when we get the derivative of that, dx dt, it's minus 12 t to the minus 3. Minus 5 times minus 4 is plus 20 t to the minus 5. Or you could write that as minus 12 on t cubed plus 20 on t to the 5. Same thing, either of those answers is just fine. So let's have a look at one from exercise 9c. You do one similar than this, but this isn't one of your questions. So find the gradient of the curve, this one, at the point where it crosses the x-axis. So this is a bit interesting, isn't it? So what do we want? Gradient here. So let's separate it out. Y equals, I'm going to write that as 2x on x squared minus 4 on x squared. So that's the same as 2x to the minus 1 minus 4x to the minus 2. So when we find the derivative of that, dy dx, we get minus 2x to the minus 2 plus 8x to the minus 3, or that, writing it with positive powers. So that's the first bit, find the gradient of the curve. That's what the gradient is at any point. At the point where it crosses the x-axis, well, when it crosses the x-axis, that's when y equals 0. So when y is 0, what is the gradient? So when y is 0, that means 2x minus 4 must be 0, or x equals 2. So basically this is saying find the gradient of the curve when x equals 2. So we sub x equals 2 into the derivative because the gradient is what we're trying to find. So dy dx equals minus 2 over 2 squared plus 8 over 2 cubed, which is minus a half plus 1, which is 1/2. So there's a bit in that. You might have to access your solutions. If there's any you're really stuck with, just email me and let me know. Good luck with 9C.